All right. Hi, everyone. Welcome back. All right, today we have James Cammarata, who's going to be giving us a talk on achieving continuous delivery, an automation story. So let's give a warm welcome to James.
Hi, everybody. Thank you for attending my talk. Really appreciate it. So a little bit about me. I am James Cammarata. I'm currently the Director of Core Engineering with Ansible Incorporated. I took over that position in early February, late January, somewhere around there. I've been a Python developer since 2003. It was pretty much my first job out of college. I was hired to convert some Perl scripts to a Zope setup, actually, of all things. So about 2008, I really started getting into open source. I had been for a while, but found out about this cobbler project. My day job at the time was kickstarting systems a lot, so a friend of mine told me about it, said I really needed to look into it. Did, ended up sending patches back, got to know Michael DeHaan very well, who had started that project. In 2010, that project was a little bit adrift, so I ended up taking it over, became the project leader. Michael, knowing me in those days when he started up Ansible Incorporated, was looking for Python developers, knew me, approached me, and so I joined Ansible in July of 2013. Been doing it ever since. So what is continuous delivery? I'm going to keep this a little bit high level since this is a novice level talk, so I will go through and define all these terms. Continuous delivery is basically the goal is to reduce the impact of deployments by doing it faster and more frequently. How many people have worked at a large corporation where you do quarterly releases and everybody gets together for the big weekend deployment? QA signs off on everything, user acceptance signs off on everything, you get into the war room and you deploy it and inevitably something breaks. So you end up, in worst case scenario, you end up having to roll it back and do it all next weekend all over again, and the higher ups are very upset and want reasons why it failed. And the worst case scenario, it takes you as long or longer to roll back than it does to do the actual deployment. I know at a previous company, basically the deployment took a day and rollback took an entire day so that we could restore everything from backup. About a terabyte of data. So it can definitely be very, very painful when those big bang deployments fail. So it was really popularized by the book Continuous Delivery, the full title's there, written by Jez Humble and David Farley in 2010. The concept had obviously been around a bit before that, but their book really brought it into the mainstream. It's an excellent read. I highly recommend it. So I'm going to show you a little video here of kind of how I envision continuous delivery working in a very real sense. So I don't know if anybody has seen one of these. They call them the Great Ball Contraptions for Lego. It's basically very intricate ways to get a ball from A to B, and people spend lots of time creating these setups. I think this is the perfect metaphor for a lot of production setups where you have a lot of things interacting in very difficult ways. And this video, I've probably watched it 10 times this week because I love it. And when I'm doing QA at the end, I'll let the whole thing play. But he basically shows this red and blue ball going all the way through this contraption and all the very myriad ways it does it. It's really, really cool. So I'll show more of that a bit later. But yeah, at the very end, the balls come back in and they're dumped back into the bin where they started, and the whole process starts over again. So that's continuous delivery in a nutshell. So obviously, I'm with Ansible. I'm a very big proponent of Ansible for many reasons. Why use Ansible in your continuous delivery setups? Well, the first reason, the reason Ansible is, to my opinion, the most popular one of the most popular configuration systems out there today is it's simple to learn. You don't have to install anything on all of your endpoint systems. Ansible just uses the existing SSHD to go out and contact all these systems and execute a little bit of Python code on them. So you just need SSH and Python. In some cases, you don't even need that if you can execute using the raw module, but I digress. Second, the playbook syntax, and generally the syntax overall in using Ansible, is incredibly simple and easy to pick up and learn. It's all just YAML playbooks. It's all just very linear tasks. One task executes after another. You don't have to worry about odd ordering that Ansible tries to determine. The order you list your tasks is the order they are executed in. So it can be very, very simple to pick up that way. Of course, the downside to simplicity can mean that it's useless, and in Ansible's case, it is far from that. With Ansible, you can orchestrate some very, very complex tasks. Pretty much the gold standard one we always talk about is, say you have 100 web servers, and you need to do an upgrade and a rolling reboot of them. They're behind a load balancer. So you say, OK, 5 at a time, I'm going to take 5 servers out of the load balancer, upgrade them, maybe reboot them, do other things, and then when that's done, reinsert them into the load balancer, and then move on to the next 5. Doing things like that is what Ansible really excels at, beyond just the simple file package service management that pretty much every configuration management system can do, and all of them do those very well. A similar situation that came up, somebody brought it up that they used it for, was migrating databases. For instance, you can, if you want to migrate your database, you can use Ansible to insert a new primary, wait for the sync to finish, take the old one out, and then you've got your new master database, say if you wanted to upgrade to a larger instance or something like that. It's also very common to have, for people that are doing immutable infrastructure, to use Ansible along with something like Jenkins or not to basically rebuild their golden images, whether they're AMIs for EC2 or even the heavyweight VMs or now Docker containers. Obviously, everybody's talking about Docker. It's very common to see that in use as well. I'll talk about one of the case studies I'll go into later actually does that. And finally, obviously, in that same scenario where you're operating on your systems, in addition to taking out a load balancer, you obviously have to deal with your monitoring system so you don't start alarming when things stop and start and reboot, or maybe it detects that the system's a little degraded. So Ansible can just as easily be used to add and remove systems to your monitoring services as you're going along. So next is reusability and consistency. When you're writing Ansible playbooks, they're generally very general. You don't have to tweak them a lot if you run them on this set of servers versus running them on this set of servers. So your developers, in whatever environment they're standing up to do their testing, their development work, can very easily use the exact same playbooks that you are using to set up and configure your systems in your production environment, your staging environment, QA, wherever you're working. It's likewise your CI system, whether it's Jenkins or Travis, whatever, can use those playbooks as well. And it's, that way you're guaranteed a degree of consistency across all of your environments, and you're just removing variables that might impact your deployments at a later date. Finally, extensibility, or not finally, but extensibility. Ansible comes with around 250, I haven't counted recently, but there are a ton of modules that we include with Ansible. Anywhere from doing, like I said, the simple file package service management on a wider range of distributions, even Windows now, all the way up to deploying full cloud environments in Amazon or Rackspace, several others. We support pretty much every one of the major ones. Inevitably, you might have some in-house service, something you've written in REST, or something else that you want to interface with, and you want to write a module for it. Well, Ansible is extremely easy to write modules for. You can take a look at some of the modules we have. They're typically very simple, straightforward little Python scripts that, if you've been writing Python for a year or two, you'd have no trouble understanding what they do. There's not a lot of complexity to those usually. The complexity usually comes in with the API you're dealing with. Like, for instance, obviously the EC2 using Bodo, those can be a little complex, but that's because there's a lot going on there. So finally, others have already done this. And I'm going to go into, like I said, case studies later on, a couple companies that have publicly advertised they do this. There are a lot of others that I'm not even going to cover that have blogs out there where they go through how they're doing all of this with Ansible or other systems, and they have, in the case of Ansible, they have a lot of times shared their configuration setup on GitHub or other places. You can go and grab their playbooks and tweak them as you need and basically get up and running in an environment very, very quickly. Also, Ansible's user community has just exploded over the last 2 years. I think we are very frequently hanging around well over 1,000 users in our IRC channel. And our mailing list has about 2,000 subscribers to it. So I'm very, very proud of our community. And all the open source projects I've worked on, it is by far one of the best. It's always very cordial. Everybody's always very nice, and beginner questions aren't mocked at all. So it's very easy to get help from our community, I think. So some of the common patterns you'll find with continuous integration nowadays. This is from one of our blogs on it. It kind of shows a high-level view. I won't get into it too much. But the continuous integration system obviously is the cornerstone to continuous delivery. A lot of people use Jenkins or Travis nowadays. Atlassian has Bamboo, and there's several others. But that is basically the system that does all of the work for you. It's your automation system. And whether you have it doing just basic tests, building things, or actually having very complex multi-step jobs over matrices of distributions and other things like that, most of those will get you what you need. Obviously, we use Jenkins internally and do things. We use Tox and some other things to do testing across multiple Python versions. And whenever we do an Ansible deployment, we do it all through Jenkins to do all the, upload our tar to PyPy and all that. So it's a very, very useful system. Obviously, to a room full of developers, don't really have to discuss the importance of source control, but one of the important things to remember in these systems is to not only keep your application code in your source control, but to also keep your configuration management information in source control. As we call it now, infrastructure is data, not code, because we actually look at playbooks as one level higher than the infrastructure as code because they're so simple to write and just really a higher level abstraction to us than, say, writing Chef configuration, which is Ruby code. Second important consideration in source control is to integrate it with depending on which one you're using, we always use Git, but to integrate it with webhooks or automated commit hooks so that whenever a commit is pushed into your source control repository, it kicks off a chain reaction of events that does your automated testing, maybe deploys to a couple environments, maybe even as far as, like it says at the bottom, to get pushed all the way out to your production systems if no errors have occurred along the way. Some people don't like that. Some people like having that human gap between production. It depends on what you're comfortable with. If you're really confident in your automated testing, then you can pretty much go the full mile. Which brings me to the next point, automated testing. Obviously, this is how you have that continuous integration system working and confident that the code you're pushing out does what you expect it to. So integration testing, unit testing, and user acceptance testing, doing things like Selenium or Ghost and Casper.js for if you're doing web interfaces, if you're doing AngularJS, running your AngularJS tests, what have you. It's really important to make sure that you have confidence in your automated testing suite. So monitoring is probably one of the most overlooked aspects of continuous deployment. It is also one of the most important because when you're pushing out releases very, very quickly, you need to know when something went wrong. So this graph is from Etsy's Code as Craft blog, which in 2010 they had an excellent blog entry about how they capture this information, not only from the systems, the logging, but also from their deployment systems, which as you can see in that graph are the vertical lines. Each one of those vertical lines is a deployment. And you can see in this graph that they did a deployment and then PHP warnings started spiking. They did another deployment and that took care of it. They realized they had a problem, so they fixed it. And then there was just a little bit of a problem left over. Another deployment knocked it out. So catching that information that you can then use to graph in interesting ways and compare to a lot of other different data sources is very important to very quickly isolating problems and getting them resolved in production quickly. There's an excellent blog, which I won't go into too much here, from DigitalOcean on setting up Graphite, StatsD, and CollectD, and getting those all working together to basically catch this kind of information. So I have a little resources page at the end of this that I'll leave up, and also when it's online. So finally, ChatOps. This is somewhat of it kind of came on around the whole time the continuous deployment was kicking off. This is a term coined by GitHub in 2009. And the main problem they saw was GitHub was extremely distributed. Beyond their core set of founders, they were very, very distributed worldwide for their teams doing all of these deployments. And they needed a way to get everybody in a room, so to speak, that was very geographically dispersed. So they determined that the best way to do that would be to automate everything through chat commands. So they wrote a chat bot called WhoBot there, that's the logo for it, that basically they could issue commands to, and then WhoBot on the back end would go out and contact services via their APIs and kick off commands, whether it's Jenkins or, other systems. How many people have heard the single pane of glass term? Companies I used to work for, it became like a very, very derogatory term. It was used very mockingly. But as far as I've seen, ChatOps is about the closest I've seen to a single pane of glass in practice. So it's very cool to see that concept actually working. So some of the benefits of ChatOps is everybody knows what everyone else is doing. You see people in the chat room issuing commands and doing actions. So there's a very high level of transparency across the teams. A lot of times you'll also see things like Jenkins build status, even some logging output from other systems. They'll feed those into other chat rooms that people can keep an eye on, and you don't have to hop around a whole bunch of different interfaces to get an idea of what's going on. You just switch between chat rooms. Because of this transparency, it's very easy for new users in your organization to come on board and see how things work. Also, these chatbots also typically have pretty involved help menus, so you can say, chatbot help command, and it'll tell you how to issue a command. For people that are used to the CLI, this is probably nothing really new or interesting. It's something CLI people have known for a long time, but for ops people that may not have that desire to learn the CLI, this really helps increase efficiency and communication. Communication is, again, very, very instantaneous. You no longer have all of these breaks in your communication where email or calls are going on, or something breaks and they say, okay, everybody get up and go into the war room. We're going to figure out what's going on. And then, a VP comes in and says, give me a status update right now. Everybody's in the chat room, including those VPs and hired up. So they see what's going on and what, like the real-time status of what's happening for any given issue. And finally, time to execute actions is greatly reduced. It's as long as it takes, to type the command to do something and to kick it off. You no longer have to, like I said, hop to another systems interface and click on a button and wait for that status and then go to another system, like, go to Nagios and disable things or anything like that. It's all, pretty much automated for you on the back end. Just type a single command. So some of the case studies I'm going to get into. The first is Atlassian. I don't think I have to speak too much about who they are. Atlassian's a pretty well-known software company. I apologize if that slide's a little bit small. Obviously, they do Jira. Anybody used Jira in the past? I'm sure a lot of people have. They recently bought HipChat and Confluence, the wiki and other data management system. They use Ansible in their continuous deployment setup to tackle what they call the last mile problem, which is how they do that complex orchestration of pushing their build artifacts out to their systems. So from their blog that they go into, which are going to be in my references point at the end of this, Their developers do everything on feature branches specific to them, and they have their continuous integration, which is Bamboo, testing against each of the developers' branches. When that's good to go, they then merge that feature branch into their release branch. Bamboo is kicked off again, builds a build artifact, which in this case is a binary, and they then use Ansible in each of their staging, QA, and production environments to push that exact same binary to each one of those environments, ensuring that nothing sneaks in there. They know if their environments are the same and the binary is same, things should work from environment to environment. So some of the advantage of this, obviously promoting the same build, like I just said, it's consistent, they know it. Number two, their blog goes into, they definitely take time out to mention that just because they're doing this with the products they offer, their methodology is very interchangeable with just about any other tool that you could kind of insert into any one of these slots. For instance, you could use Jenkins instead of Bamboo, or you could use something besides Ansible if you really wanted to use something else. The disadvantages, in my opinion, and they're reading their description, they're very siloed. They have individual teams that have their turf for each environment. It's not very DevOpsy. It's very, very siloed still. It's the enterprise way of doing things, which is working for them, but in my history, I've seen it kind of break down when you actually do run into problems at times. So Rising Stack, this is a little bit of a smaller company. They're doing JavaScript consultancy. They do code reviews for companies writing JavaScript, some other things. They use CodeShip, which is a third-party kind of a continuous integration as a service, which obviously Travis kind of is too. And a custom service, which they call the Docker deployer. There at the bottom, that's something they wrote in-house that basically just listens for a webhook call. So from their blog, the way they describe it, they have all of their devel goes into the master branch, which kicks off via a webhook on GitHub to CodeShip. It does all of their testing and all their integration testing, all their other testing. And then if that passes, they contact Docker Hub to build a new Docker image. Docker Hub also supports webhooks on actions, so when that image is done building, that webhook is fired to that in-house service they wrote, and that essentially just runs Ansible to deploy that new Docker container out to their environment and starts the new one, stops the old ones, whatever they need to do. So yeah, that's about it. They don't really go into too much about that and how they do it, if it's very complex for them to push that container out, but knowing Docker, I don't think it's very complex. So Rising Stack continued. Some of the advantages, completely automated. They don't have any human intervention past that initial commit. They rely on their testing, and if there's a problem, it's pretty easy to just go ahead and do another fix or roll back to a previous version of that Docker container. Some of the disadvantages, obviously they wrote that in-house service, so it's something they have to maintain when doing something like Jenkins or something else might have worked just as well. So Big Panda, we love Big Panda. They are very big fans of Ansible. They spoke at our last Ansible Fest in San Francisco. They're centered around automating incident management. So they basically correlate events and some other information and try and help you pin things down when you're having a problem. They use ChatOps and Ansible very, very heavily in their day-to-day operations. They typically say that they have a operations team of one. It's just one gentleman who basically manages everything, but being a very small organization and having everything in chat, everybody else can pretty much see what that one person is doing, and they can kind of take over if he's unavailable to do something. They wrote a very nice blog about us, 5 reasons we love using Ansible for continuous delivery, so if anybody wants to read that. And one of their mottos that they bring up in their presentations is take the hardest part, the scariest part of your build, and make it the easiest, which if that makes total sense, that if something is hard to do, tackling that, get the big wins first so that you can then work on something that isn't quite as difficult to figure out. When you figure out the hard things, everything else is easy. So this is, they use Hubot, which I mentioned earlier, and HipChat. They renamed Hubot to Beanbot internally, and they have a little mascot there, which is a panda driving a larger panda mecha, it looks like. It's fun little stuff that they do. But yeah, they basically just, it's very straightforward, similar to Atlassian when you get down to it, where you have Ansible in the back end doing everything to do all those deployments after your continuous integration system is done with the build artifact. So finally, Grasswire. This is our kind of obligatory Tower plug. If people don't know too much about Tower, Tower is our enterprise product. It offers a couple advantages, like a REST API that you can integrate with, so you can have things talking to it directly. They're also a big ChatOps fan at Grasswire. They use Slack instead of HipChat or anything else. One of the really cool things about Slack is that you can have it natively do webhooks from the interface. You can do add-ons to it without having to have a full-featured chatbot in your environment if you don't want to have to maintain that running somewhere. So pretty much their workflow is they use Packer to build new AMIs, which they push into EC2. They use Terraform, actually, which is a nice command line program to do kind of complex EC2 environments if you're not happy with cloud formation and still want to fire everything off in one giant environment build. They say that they're able to do more complex networking setups with it that way. Once they have their environment up and running, they use Ansible to deploy their build artifacts into production, just like everybody else. Use the Ansible EC2 modules for the Elastic Load Balancer to take things out of Load Balancer, just like I said. Stand up database systems, what have you. They did mention in their blog that they originally were baking their build artifacts into an AMI every time that they basically changed anything, and they found that to be a really, really heavy-handed approach to do things. So they ended up reverting that and splitting it into two parts. So that may be something you consider. Probably less of a problem with Docker, but when you're doing full-featured VMs, definitely something to think about. So one of the other kind of cool features they use for Packer is Tower provides this provisioning callback system. So instead of having to, in your Docker or Vagrant file or anything else, you just make this callback to Tower and say, hey, come configure me. And it will, based on your the host name that you ask it for, it will drop whatever configuration roles what you want that system to do on in your environment. This is their provisioning little snippet from their Packer file, and it just shows they just drop a shell script into their rc.local that gets run when it's building. So pretty easy setup. And also, since they're using Tower, they're able to use the Tower CLI command, which is just a CLI command, like obviously it says, to go out and trigger jobs in Tower. So they don't have to write out Ansible playbook and then the name of the playbook and all these other things. They have all of these discrete jobs set up. So pretty simple setup. So some of the tips and tricks I picked up from reading all of these blogs and kind of going through and seeing how companies were using us. It's not too many, but first and foremost, use Ansible to build these environments. Like I said, there's tons of roles out there to basically install every one of these components in any manner you so desire, whether it's bare metal in your data center or in Amazon or Rackspace, wherever you want to build it. It makes it, just saves you a lot of time. You can also, if it's not on Galaxy, you can find it via Google or GitHub. It's very easy to find them. Second and last tip is just use Ansible from day one, and this is true of any configuration management system. If it's worth your time to go out and SSH to a system, it's worth the time to just write it into your playbook immediately and then just run your playbook. It will save you the time later of trying to figure out what you had to do to get something configured, and inevitably, forget to enable a service when you install something, and something gets rebooted 100 days later, and then nothing works when it comes back up. So that saves you the time and trouble of having to fix things down the road. So, ready for Q&A session, if anybody wants to come up to the microphone.
There we are. If you have any questions, all right, people are already there.
Hi, I have a question about Ansible and Docker. So you mentioned that Ansible can work with Docker, so it can start and stop Docker containers?
Yes, yeah, we have a Docker module and also a Docker image module for building Docker images. They can be used to start and stop containers, download things from Docker hubs, whether private or local.
So does that mean that we can use Ansible as another kind of Docker orchestration tool?
Yeah, absolutely.
Oh, cool, thanks.
Yeah.
So a lot of these folks are using a lot of commercial services, GitHub, HipChat, Docker Hub. That's a huge attack surface, and most of these are putting kind of their crown jewels of their company in these services. So I'm wondering if there's, you want to use these things because they're public and they're easy to use and you don't have to run them in-house, but what are some of the ways that you can protect yourself against, say, a compromise of one of these services or their authentication fails and someone gets into your chat room who shouldn't be there?
Sure. There's a lot of ways you can tackle that. You can build some of the authorization into the chatbot that you're running. There's a few other ways you can do it. If you're using Tower has additional role-based access controls. It really depends on how far you want to take it. Instead of using GitHub, you could install something locally in your environment like GitLab, or even just an SSH Git repo if you're really paranoid about having your source code out. So there's a lot of options, and people obviously take a lot of different routes with it. So if you're always paranoid, you can always bring things in-house. There's always open source projects that basically will provide you the same kind of functionality. You can run an internal IRC server. You can run, like I said, internal source control. So it just depends on how far you want to go with it. You always have to remember, too, that a lot of these third-party services have incredible services teams, too, and they're constantly fending off attacks and other things like that, like the DDoS against GitHub over the last few weeks.
For someone who would like to create a module, can you recommend one module right now that is a good starting point to understand how Ansible modules work, and one that is easy but works across different operating systems?
Sure. There's a couple that come to mind, like some of the things in extras. Like if you want to see how some integration with third-party APIs work, you could look at the HipChat module, for instance. Some of the more basic ones that are like kind of the core important ones, like copy and service, are actually really, really complex. I wouldn't necessarily recommend looking at those, but there's a lot. Yeah, talk to me afterwards and we can kind of discuss some, but yeah, there's a few that pop to mind.
Another Docker question. Say I want to use Ansible to run one command on a number of Docker containers. It's actually considered a better practice, as far as I know, to not use SSHD in a Docker container. So how would it be possible to do with Ansible?
Yeah, so Ansible actually does have some alternate connection methods. You can actually have, if Ansible is running local to the Docker container, you can have Ansible connect over, I believe, either libvirt or some of the other methods to connect to the container, not over SSHD. They're still kind of new because not a lot of people have really done that yet, but the option is out there, and if it needs improvement, just let us know. We can always work on it, make it better.
So you talked about monitoring, and I'm curious, how does Ansible work with, say, Nagios in the back end, where does it turn it on off automatically? Is there some sort of module built into Ansible that you just point it at your Nagios server, or do you actually have to know the calls to the Nagios server as if you were turning it off in the command line?
Yeah, so there's actually a Nagios module. It can be used to disable and re-enable a service name. Typically, we have in Ansible what we call a delegated to action. That means rather than running it on, like, say you have this list of hosts, 1 through 10, and rather than running it on any host 1 through 10, we say delegate to the Nagios server, and Ansible then goes out and connects only to the Nagios server and runs that module there. So yeah, it's just if you look at the documentation on the Nagios module, you'll see how it's you don't have to know any of the nitty-gritty details for it.
Hi, in my organization, we're in the middle of implementing SaltStack. And since coming to PyCon, I've been hearing a lot of positive things about Ansible. What would be the arguments or reasons to switch over to Ansible?
Yeah, obviously we always tell people that ask us questions like this, try them all out and find the one that works best for you. We just typically find that people pick Ansible for those reasons of simplicity that I mentioned. No required agent on your systems is obviously a huge bonus. SaltStack does offer an agentless mode, though, correct me if I'm wrong, last I heard they still kind of recommended that you not use that for production setups. And then beyond that, I believe, I have SaltStack is one of the ones I haven't used actually, but I believe they still do things in a very declarative way, more along the lines of how Puppet works, where there's not a strict ordering. Again, correct me if I'm wrong, but I thought that was one of the other primary differences. So yeah, obviously Salt and Ansible share a lot of the same stack under the hood with Python and Jinja 2, and a lot of the underlying technologies are very similar. It's just we kind of took a slightly different approach to it. So.
Okay, cool. Thank you.
No problem.
All right, I think that's it. So thank you, James.
All right, thank you.